think you guys are going to be on candid camera today, so just so you know. I'm going to try to help out Sammy and Grayson being out. All right, our last two lessons of this chapter involve graphing trig functions. So that's today's lesson and Monday's lesson. Both involve graphing trig functions. And so what we need to learn is we've got to learn what they look like first off. So grab your calculators. You're going to need it. If I make this statement, finish it for me. Anything can be graphed using an XY chart, exactly. And that's what we're going to do here. And that's what I have started for you guys in your notes, right? I've got an XY chart for you. Let me first help you to understand what's here, because sometimes the language makes you feel like I'm talking in Russian or some other language. Remember, f of x is synonymous with y, right? So this is the same as y equals sine x. And we're trying to graph the basic sine function. What is the graph of a sine? That's what we're after. Now, let me show you, don't put this in your notes, let me show you the radial view. Remember that problem? I don't know, it was like 8 point something pi radians, and the other one was like, I don't know, 1,400 and something degrees. And remember how you could just go around and around and around, right? And you can. And so it's the same way here. These go forever that way and forever that way because you can keep spinning around. 360, 720, 1080, 1440, etc., all the way positive, and you can go all the way negative as well. These things just keep on going. So what we usually end up doing is we tell you, hey, only graph it between this amount, because how can you graph for forever? So that's what this part is. Hey, only give the function from 0 to 360 degrees. Now also notice this. The x-axis of the graph is the angle measure, right? 90, 180, 270, 360. Notice the x-axis contains angle degrees. Therefore, the y-axis is going to contain the ratio. The y is the ratio. For the sine, always the opposite over the hypotenuse. And its value, and we're going to get the value in decimal form. That's what our calculator does. Okay, so trying to do two things at once. But your brain thinks better in degrees than radians, so I'm going to do everything in degrees for you. All right, so we'll do it in degrees. But to the left there in your chart, if you look, I also have the radian equivalent. Right, 0 degrees is 0 radians. 90 degrees is pi over 2 radians. You don't need to circle that. I'm just trying to get you focused. 180 is pi radians. 270 is 3 pi over 2. And 360 is 2 pi. To be honest with you, your book asks you to graph in radians. And quite honestly, you guys are struggling with what trig is in its essence right now. And you think way better in degrees than you do in radians. So I'm really looking for you to graph in degrees, keep you from getting too confused, but I do want to show you the comparison. All right, so let's go through and graph this using an XY chart. So take your calculator, punch in 0, and hit your sine button. Punch in 0 and hit your sine button. I'm going to do these in blue. And everybody says the answer is 0. Okay, now that's the ratio, that's the y value. So we are right there at the origin, right? Can't see it too well, but there's a blue dot right there at the origin. All right, to help us with this first one, I put in 45 degrees, which, by the way, that's going to be right there, right? 45 would be halfway between 0 and 90. All right, so punch in 45, hit your sine button. Is it 0.7071? 0.7071, what's the next digit round off? 0 or 1? 1, okay. 0.7071. All right, so we're guesstimating. So 0.707 is probably somewhere about there, right? Decent guesstimate. All right, so I went to 45 degrees and about 0.7 up. can go for a 7 up right now. All right, punch in 60 and hit your sine button, or your sine button is 60. It's 0.866. What's the last digit round off on that one? 0. 0.8660. So we're climbing closer. Okay, let's see, 45. So 60 is a little trickier on your graph. Oh, let's see, 45, 55, 65. This is 67 here. So 60 somewhere about in there. That's close enough. And 866 is maybe somewhere about there, right? We're only going to do this one time to begin to get you guys to understand. All right, punch in 90. Hit your sine button or sine button and then 90. And class says the value is 1. All right, so at 90, we are up to 1. Now, we don't have this on the chart, but just so you understand, punch in 89 and hit the sine button. 0.99 something, right? Okay. Punch in 89.999 degrees and hit your sine button. 0.999, whatever, right? Okay. Punch in 90.01 degrees, 90.01. 1.00 something. Round it off. Yours is rounding off. Punch in 91 degrees, hit the sine button. It's less than 1, correct? All right. We're heading back down. All right, so the next value we have is 135. That's halfway between your 90 and your 180. So punch in 135, hit your sine button. What do you got? 0.7071, right? Oh, symmetrical. Math is so nice. All right, 0.7071. Punch in 180, hit your sine button or sine, and then 180, and you get, what do we get? 0. So 180, we're at 0. 180 at 0. 180 at 0. So 135 was 0.707. 180, we're at 0. All right, and from this point on, we just need the key values. And by the way, the key values are the ones I boxed in for you. So 270, hit your button. What do you get? -1. So come to 270. Be careful now, -1 is 2 spots down, so right there. Punch in 360, hit your sine button or sine, and then 360, and your calculator says 0, and we're back to 0. So I'm going to take my red, and I'm going to try my best to draw a smooth curve, hitting all these points. And really, I'm going to go just a tad past with an arrow, and just a tad past with an arrow. And there is your basic sine wave. Now that's a shape we should know and a shape we should learn. Okay. This is considered one wave. One wave. From 0 to 360 is one wave. Any idea what the highest point of the wave would be called? Anybody? Highest point? It is the crest. It is the crest. Highest point is the crest. Anybody know what the lowest point of the wave would be called? Anna? It is the trough. How in the world do you spell trough? T-R-O-U-G-H? Is that trough? It is the trough. They do, exactly, because you know what? Sound waves are waves, and a sine is a wave. It's a sine wave. The 0 on the y-axis, the x, this 0 off of the y, and the x line, we call this the rest position. It's kind of the balance position between the up and below, right? The above and below. We call it the rest position. And notice the amount it rises Above the rest position is the amplitude, which is exactly the same amount for a basic wave that it falls below the rest position, is the amplitude. Amplitude, amplitude. Hey! Oh, I just made the amplitude of that wave a whole lot higher, didn't I? Sorry about that. Probably blew out everybody's speakers at home. Sorry about that. We messed up your speakers at home. I take no responsibility. All right. Right, a sound wave, that exactly what happened was we took that wave and we jumped up its amplitude. If you have an amplifier, what is it doing? It is taking that wave and it is increasing the amplitude of that wave. And that's what's going on. So again, this is a basic wave. Sound is complex. If any of you have done any computer programming with sound, you've seen a lot of waves. Well, sound is a lot of different things together, all together. And therefore then it's jagged ups and downs and all that kind of stuff because there's a bunch of waves at one time. But that's the basics. In addition to that being one wave, let me go back to my green here, the number of degrees, so this is 360 degrees, is called the period. The period of the wave. We're going to use that a lot here coming up. Because remember the beginning illustration where we can go round and round and round she goes, and where she stops nobody knows. This wave keeps repeating every what? 360 degrees. If I go from 360 to 720, the wave will look exactly the same that next 360 to 720. Exactly the same 720 to 1080. Exactly the same 1080 to 1440. Exactly the same 0 to negative 360. The wave just keeps repeating. Along it goes, along. All right? The aspects of a sine wave. So, key points. I'll use my blue here because I use blue there. So, all the boxed in points are points. If you'll learn the key points, the 0, the max point there, which we call the crest, back to the rest at 0, halfway, right? You're back at 0. 3/4 of the way, you're at the minimum. And at the end, you're back at 0. Start at 0, first quarter mark max, halfway 0, third quarter mark min, last mark 0. Key, right? So I'm going to come over here and next to the quarter mark, matter of fact, well, I'm going to write max, right? And then next to the 3/4 mark, I'm going to write min. If you know those, you can graph anything, and that's what we're going to get into a little bit today, mostly more on Monday. So that's a basic sine wave. Let's go to the basic cosine wave. Go a little bit quicker here. We only need the key points in the cosine wave because you already now believe me that that's the shape. Now, by the way, you need to learn the key points because if not, you just try an XY chart. If you don't know what's going on with the wave, then you could find all the points in one area and think, for example, let me show you. Don't put this in yours. So let's suppose you don't know what the wave looks like, and you just find a bunch of values on your calculator. And let's say you start punching in numbers like you normally do in algebra, and you punch in 1 and 2 and 3 and 4 and 5 and 6. Here's what you'll get, and then you'll say, okay, I guess the wave looks like that. Well, yeah, you found all true points, but the problem is you don't know what the wave looks like, and therefore now you didn't find enough points to give the shape of the thing. Everything you did was true. It's just you didn't give enough points to really show what it was. And so it's important that you learn the basic shape of these to help you along. All right, so we've got these key points. So take your calculator out again. Remember, we're doing the cosine this time. We're still going 0 to 360. So that's going to be one wave again. Punch in cosine and 0, and your calculator says 1. So the cosine starts off at 1. Oh, by the way, the basic sine cannot go bigger than 1 and cannot go less than -1. Punch in any angle you want. All right, let's do this. We'll take a second. Hit your sine button. punch in 20,000 and hit equals. You will not get a value bigger than 1 or less than -1, right? You can play until your fingers, you wear your fingers to the bone, and you'll never get a value bigger than 1 or less than -1. Okay? Cosine's the same way. So we start at 1. Go ahead and hit 90 cosine or cosine 90. And you should get 0. So now we're back. Now we're at 0 at 90. At the first quarter mark, we're at 0 for the cosine. Punch in 180. Now you're at -1. Punch in 270. Back to 0. And punch in 360, and you're back to 1. So again, now the key is to try to, with a smooth curve, connect the dots. Cosine is so much harder to draw, at least for me. It doesn't look pretty, but... So again, that's one wave, that's one period from 0 to 360. And what are the key points again? You see your max, you see your min. Well, notice it's a max at the beginning, right? At the first quarter, it's at rest. At the halfway point, it's a min, right? And these are the key points. If you know these key points, you can graph it. At the third quarter, we're back to 0. And at the end, we're back to a max. That's the way the cosine goes. Now, here's an interesting fact. The cosine and the sine really look exactly the same. Don't you agree? I saw somebody's eyes, they went like this. Don't you agree? Don't they look the same? Don't the sine and the cosine look the same? Oh, do they? Do they look the same? Let me back up the cosine to -90. Punch in -90, hit your cosine button. What do you got? 0. Oh, okay. I'm going to do this in red. So let me back up to -90. Oh, let's see if I can remember how to use my creative pen. I thought that was the... Alright, I thought I used the... Wasn't that it? Oh, magic pen. That's what I want. Alright. Doesn't that look like the sine wave? Isn't it? Right? Look up above. Look at that. Isn't that the same? And it is the same. And the difference is the sine is 90 degrees ahead of the cosine, right? We call that being out of phase by 90 degrees. If any of you guys ever get into electricity and stuff, you'll learn about phases and things like that. But they're out of phase by 90 degrees. There's a relationship there, all right? Those are the key points. We need to hurry on. Let's get to the tangent. All right, so let me help you out. If you punch in 90, -90 for the tangent. Oh, by the way, let's use our green here. The period of the tangent is technically -90 to 90. It's different than the sine and cosine. And it looks different too. -90, your calculator says error, right? Because the reality is, and we could do this, if I had time, I'd show it to you radially, but it's -infinity. It's the answer, -infinity. Punch in 0. That one will give you a value. It is 0. So at 0 degrees, I'm going to put a point at 0. And if you punch in 90, it again is going to give you an error or domain error, and that one is +infinity. So I can't show you negative infinity, but I'll go way down here close to my asymptote. And I can't show you positive infinity, but I'll go up here close to my asymptote there. And here is the trig function. And I could do a few more points to show the middle curving a little better, but that's the basic shape. And it's going to repeat that every 180 degrees. So watch, if I go now to 270, all I got to do is repeat that pattern. Got to hit 180, got to go up, there it is, and it keeps going like that forever. That's the tangent. Comes out from negative infinity, goes through the halfway point every 180, and goes up to positive infinity. Who knows? Round and round she goes. That's a question for Einstein. Maybe you could figure that out, Dawson. That might be possible. You never know. That's the shape of the tangent. All right, I got to get to the next page here. Okay, so I put the patterns on top of your page for you. That's the key to everything. The pattern. So I got to go fast. So hang in there. This thing tells me I got to graph negative 90 to 4 pi. Watch how you do this. So pay attention real quickly. 4 pi is 720 degrees, just so you know. Negative 2 pi is negative 90. But watch. The sine is from 0 to 360, one wave, right? So I'm going to do that first. Remember I told you start, first quarter, halfway, third quarter, end. Number one, fours. So look what I'm going to do. 1, 2, 3, 4. This is going to be 360 degrees or 2 pi, right? I'm going to use my green for vertical asymptote, vertical asymptote. Now watch, this is the key. What do I know about the sine? Look at the pattern right up here. It starts at 0, okay? Between my two green lines, I start at 0. What does it do at the first quarter mark? It's at a max. I'm going to a max. What does it do at the halfway point? It's at rest. I'm going to rest. Look at where it is on the third quarter point. It's at a min. I'm going to a min. And where is it at the last point? It's back at 0. Okay, there's my wave. Now it looks a little different because we scrunched up the scale, right? Just like if you take your picture and scrunch it this way, you'll look okay. Scrunch it this way, you're going to look enormous, right? You follow? So the scale's different, and that's why it looks a little different. It's the exact same thing. Okay, so I only went to 2 pi. How do I get to 4 pi? I got to go do it again. 1, 2, 3, 4. This is 4 pi, right? 720 degrees. It's a second wave. Hey, I'm doing the exact same thing with the wave. Where does it start? At 0. Where's it at the first quarter? Max. Where's it at in the middle? Min. Where's it at the 0? Where's it at 3 quarter? Minimum. Where's it at the end? 0. Just repeated. I just repeated it. Zoop. Okay, I've gotten from 0 to 4 pi. How do I go backwards? Well, look, keep your same scale, right? So 1, 2, 3, 4. This would be negative 2 pi. Halfway would be negative pi. So a quarter is negative pi over 2, right? What would negative 90 be? Right to there. Right? And there is the sine wave graph between negative pi over 2 and 4 pi. Now, I chose a pretty hard one to help you guys out, Aiden. It's the same shape forever and ever. Yes, sir. Repeats every, that's why it's called a period. Every 2 pi or 360 degrees, it repeats and repeats and repeats and repeats. All right. Again, this one, it would help you guys to translate. This is 540 degrees. This is negative 180. And again, when the book wants you to do pi, radians, just translate to degrees and then mark them that way. It'd be easier for you. Keep you from getting confused. So again, look, 4 marks is the key because everything's in quarters. The pattern is in quarters. So I'm going to go 4 marks. 1, 2, 3, 4, and I'm going to do my vertical line. And that's one wave. So this has to be 360 or 2 pi, right? Agreed? And again, how do I know the cosine within that 360? Where does the cosine start? At a max. Again, top of your page, I got the pattern for you to look at. Where does it go at the first quarter? At 0. Where's it at the halfway mark? Minimum. Where's it at the third quarter? 0. Where's it at the last mark? Max. Okay, cool. Draw it. How do you get to 540? Another half of a wave, right? I wish I had time. I don't. Bell's going to ring. Right? But a full wave would put you there. So 3 pi is right there. You just got to go half a wave that way. And this way, here's a negative 2 pi. So you got to go half a wave left and half a wave right. All right, get it sorted out with your homework. It's not a ton. Pay attention. Oh, I have graph paper for you. I would take it. It will help you. 426, 1 through 4, 6 through 10, 12 through 14. 1 through 4, 6 through 10, 12 through 14. And if you want, try to get them as you go here. It'll help you to graph on these. This way you don't have to make the graph. Then you should put your name on it. You may also have to use a sheet of paper. In addition, you may not need both. Maybe you only need one. I don't know. I'm just giving you 2. And I'll give you more on Monday for the other graphs. Sorry to hold you over. Getting everybody 2. Here you go. It'd just be easier on you. So you don't draw the graph every time. And the patterns are right up above to look at. Go off the pattern. Follow the pattern. It's all about the pattern. All about the pattern. Oops.